Aloha and welcome to this very cursory introduction to testing. Testing is a really, really complicated and fascinating topic in software engineering. It deserves its own class, or at the very least, a long series of lectures to do it any justice. And so I'm not going to do it justice. um, what I'm going to focus on instead is kind of getting you off the ground, getting you able to create tests and integrate them into a continuous integration scenario. And having got your feet wet in this way, I hope that it will give you a platform for becoming more sophisticated with your testing over time. I want to say from the outset that the kinds of testing and the way you approach testing for life critical applications is just a completely different ball game. I'm not going to go into any of the kind of techniques and criteria and approaches for testing life critical applications. That's a whole, it should almost be named something different. Okay. What I'm going to instead focus on right now is an approach to testing when you're kind of in the prototype stage of development. And in this kind of situation, you want testing to add value. You don't want testing to start to equal, the amount of effort you require to actual development. So you want it to increase the velocity of development and not slow it down. And the way it can do that is by helping you understand when you make a change to your code base if you have inadvertently broken something else. Okay, now again, this is completely different than in the situation of a life critical application. In a life critical application, you don't care if testing is 3 or 4 times the overhead of actual development. That's completely fine and acceptable. But in our case of kind of prototype initial development, where you're actually building the system to understand user needs and requirements as much as anything else, then having testing slow things down significantly is at cross purposes for the goal of the development process at that point. So the question is, some people might say, well, don't test at all. But in fact, you can provide tests in such a way that the overhead of building the tests pays itself back by helping you understand quickly when you make a change to the system that change has broken something else and you couldn't really see it. Maybe because you're new to the system or you've just kind of forgotten about an interaction. Okay, so as I said, why even bother to test a prototype? It reduces stress for sure because you make a change and it's very hard to always know the implications of your changes. Run the tests. If all the tests pass, you've got some assurance that your change is not breaking anything, at least in a dramatic fashion. The second thing is that when you run the tests and if something fails, that immediately gives you some information that might help you locate the source of the problem more quickly. Then finally, if you do the testing right, particularly if you implement it into a continuous integration kind of scenario, then the overhead of actually running the test is not too high. Okay, so there's 3 kinds of tests that as a beginner to testing, you want to know about these 3. There are other kinds of tests, load tests and so forth, that are also out there. But what I want to focus on to begin with is the idea of unit tests, integration tests, and acceptance tests. Okay, and let's do it through some diagrams here. So let's start with, we have this very simple, web application. And so it's got a database on the left side. And then, it's got some code that runs that interacts with the database. And then there's the internet, okay? So at the front end of the server, it's accepting HTTP, commands through a socket like socket 80. And then on the other side, there's a client in some kind of browser usually, and there's a whole bunch of code that runs over there, and then the user is interacting with it. So there's our system. So a unit test in this scenario is testing a small piece of functionality basically in isolation from the rest of the system. So you can see in this case, this little module, it accepts, it's called by one other module, but then it might be using code from two other modules on the left-hand side. So it's called on the right-hand side. Left-hand side, there's two modules that use it. So to do this unit test properly, you might have to mock up the behavior of those two modules that it depends upon so that you can truly test it in isolation from everything else. Here's another example of a unit test. You can have unit tests run on the client side code in isolation just as easily as you could do it on the server. And then the third one, I think this is the one that's that in the case of our application development is particularly important, is to test to make sure that a module that interacts with the database is doing so correctly. So the database is getting updated, or you can find things when you think you should be able to find things, and so forth. And that's a real key test that for prototype style testing. So let's look at integration testing. The term kind of suggests, the idea here is that you're now trying to make sure that some subset of all the modules in the system can actually work together and accomplish the appropriate task. So graphically, here's 5 modules plus the database. You're testing to make sure that all of them are kind of going to do the right thing. The other thing that is important for integration tests, and is actually something that in the world of Meteor, or I guess any web-based application, it's really important to see that the communication from client to server is correct. So there's a whole class of integration tests that are involved with making sure that on the client side, here's a module that depends on something from the internet, that you can actually get that information from the internet. So that's an integration test, and there, as you can see, it's still kind of a subset of the modules, and the difference with an integration test, between an integration test and an acceptance test, with an acceptance test, you are basically running the entire system, and you are mimicking, or you're testing the experience of the system as perceived by the user. So there are testing frameworks that basically bring up, the equivalent of a browser and enable you to programmatically retrieve pages, fill out forms, click on buttons, click on links, do all of the behaviors that a user could perform on your system through its user interface. And so an acceptance test is designed to mimic the behavior of an actual user using the front end, and then check to make sure that the appropriate the appropriate behaviors occur. So a classic acceptance test, really kind of the default acceptance tests, is to merely retrieve all of the pages in your application and make sure they actually display. Okay, so that will actually catch a bunch of errors in general, or a bunch of ripple effects. So you make a change, and actually your change is breaking some other page so that it doesn't actually display to the user. So that's an example of an acceptance test, very easy to write, very fast to run, and actually will help catch certain, lots of, in my experience, it will catch errors during development. Another example of a simple acceptance test is the user has a form, and so you log in as a sample user, you fill out the form, you submit it, and then you check to make sure that whatever impact that form was supposed to have on the state of the system is actually reflected in the state of the system. So if you fill out a form and you add something, you expect to see now that there were no errors on submission of the form, and B, that you can now go to some other page that lists the things that you've added, and it should appear there. Again, fairly simple test to perform. Is is can fairly easily be broken by some other change to the system, and so is a good candidate for an acceptance test in a prototyping scenario. Okay, so in the JavaScript world, to do unit testing, there are kind of two kinds of libraries you have to worry about. You have a library that enables you to assert whether something's satisfied, so an assertion library, and Chai is one of the most popular. And then you need another kind of library which basically takes these assertions and brings up the system and runs those assertions and collects the results and so forth. And those are called test runner libraries. And so there's a bunch of assertion libraries, there's a bunch of test runner libraries. In this class, what you're going to see is Chai and Mocha are the two that we're going to use, but there's a bunch of other ones, and they're you can certainly choose other ones if you find them to be preferable for other kinds of development. In this class, you got to use the ones we talk about. So the idea of assertion languages, they're meant to be pretty readable, and so here's an example of Chai, and the idea is you start off by saying expect, and then you have in parentheses some expression or some command or something happens inside those parentheses, and it should have some result value, okay? And then that result value you can test for various properties by chaining together these other kinds of functions, okay? And so it turns out that JavaScript enables you to drop parentheses if you're not needing them and so forth. Then you end up having this kind of nice looking syntax that is very readable and enables you to kind of just look at it and understand what the expectation is for foo. All right, and so how does this all kind of come together in actual code that you're familiar with looking at? Here's an example of a unit test. We have a collection called interests, and we want to test it, and so I'm showing you a really simple example of how you might do that. You have to import the Chai assertion language so that you can use it. And we have a test runner, Mocha, which we will use to actually run this test. And so you have this describe function, which is actually part of the Mocha language, and we have this ESLint NV Mocha we add to this file because you don't see an import of describe. So this is why we don't get any ESLint errors for those who are checking. At any rate, what we want to do is we want to say, want to make sure that this code we only execute this code when Meteor is running its server-side code. It's one of the interesting parts of Meteor. Meteor, you can have JavaScript code that runs both on the client and the server side. That's a really huge feature of Meteor with a lot of really positive implications. But it means that when you are writing code that should only run on the server side, you have to explicitly indicate that. And so for unit tests, and the unit tests that I'm expecting you to write for 3.14, they would all be server side, checking to make sure that the database and the server interact correctly. And this is an example of such a test. Basically, we're going to create a new interest, a fake interest name. We're going to insert it into the collection. Then we're going to make sure that we can retrieve it from that collection later. Integration tests in Meteor, in Meteor applications, to me, the most interesting kinds of integration tests for prototype-based development are tests that check to make sure that Meteor methods execute correctly. And these can be a little more complicated. We have to use the async await forms of ES7, ES6 to provide functions that return promises to make sure that we can deal with the real-time nature of doing things like logging in, which may take some period of time, and with making sure that subscriptions that you that are on the server side, subscriptions invoked on the client side to populate the client-side database actually run before we call some method that's on the client side to communicate with the server side. So these are a little more complicated. For ICS 3.14, I'm not going to require you to write integration tests. ICS 4.14, that's another matter. But I actually want you to focus most of your energies in 3.14 on acceptance tests. And I want to do that because acceptance tests, because they test the most parts of the system at once, in some sense you get the most bang for your buck. So you write an acceptance test and you're kind of implicitly doing an integration test or executing code that involves multiple modules, and thus you're invoking code from a single module. So in some ways you're getting all the other flavors of testing at once. Now the big downside is that when an acceptance test fails, there's a whole lot of kind of surface area to your application that might have been involved in the problem. And that's the thing that's really nice about having unit tests plus integration tests plus acceptance tests, is that if a unit test fails, you don't really worry about what's failing at the integration or acceptance test level, because you got a unit test that you've got an isolated module that's not doing the right thing. You just go focus, you fix that, then you rerun it, and then you kind of work your way up. And so if an acceptance test fails, while none of the integration tests or unit tests fails, that means that it's probably fairly isolated in the user interface, for example. At any rate, here's an acceptance test, and it looks very different from other tests in that what you're doing is actually manipulate. You're going to a URL, and if you kind of read this, the landing page is displayed, and then we use the nav bar to go to the sign-in page, and then on the sign-in page we sign in and we provide some credentials. So it's like we have a little robot script here that's going through actions that a user might take. And this, in the case of Bofolios, we organize our testing acceptance test code following this design pattern called the page object model. And that means that there are classes. You can see there's a class here called navbar and a class called sign-in page and a class called sign-out page. We create these classes to represent various pages and other significant components of the system, and then we write methods to manipulate that part of the UI in ways appropriate to whatever part of the UI that is. So on a sign-in page, we have a method to sign in, because that's what the sign-in page provides. And that enables us, when we write these other classes, these kind of utility classes, it enables us to have our actual test code be very readable and very short. And it enables us to actually reuse code across multiple tests. So it makes it easy if we have to sign in in multiple tests. We just call this sign-in page.sign-in, and we don't have to copy all the code for filling out the sign-in form and clicking the login button and all that. So anyway, there's an example of an acceptance test. So let's say we've written all these tests, and that's great. We have all these tests, and then but tests aren't really that helpful if you don't actually run them. And so one way you can do it is to tell all your developers, hey, run the tests. It's really important, run the tests. Are they going to listen to you? Who knows? Okay. So another strategy is to tell the developers, hey, it's in your best interest to run the tests. But even if you don't run the tests, whenever code gets checked into the master branch, the tests will be run automatically. Okay. And that idea that there's an automated process that checks the quality or other aspects of the system automatically when the code is added or integrated into a certain branch or a certain area of the repository. In our case, the master branch or main branch. That is continuous integration, and it's a phenomenal asset to development. There's Jenkins, there's Semaphore, there's Circle CI. There's a bunch of different services, cloud-based services out there to provide continuous integration facilities, and they're great, and depending on your needs, one of them could be better than for the other. The one that it's a relative newcomer, but the one that I've found to be really the simplest for our tech stack is called GitHub Actions. And the idea here is that you can create a subdirectory of your repository called .github, and inside you can have a directory called workflows, and inside that you can have a YAML file, and here's an example of one. And what it says is whenever there is a commit or a push to the master branch, then we'll say define the working directory, so all these commands will take place in the .app subdirectory. And we're going to create a job, and that job's going to run on the latest version of Ubuntu, so Linux. And we're going to check out our code into this Linux virtual machine. So we'll check out this repository, the Bofolio, in this case Bofolios. And then we're going to add the node program to our virtual Ubuntu server so that npm works. Oops, sorry. And then we'll run npm CI. That's like npm install. It's a little bit more secure version of it. Basically install all the libraries for our package from the package.json file. And then we'll install Meteor. And then we'll call Meteor npm install to install our packages. Meteor npm run lint to run our ESLint package. Test unit to run unit tests, and testcafe.ci to run our integration tests. So it's super simple, as you can see, to create a continuous integration service for our applications. If you go to GitHub, and after having committed to the master branch, you can click on this Actions tab up here, and you can see what happened when I committed, and in fact I got this workflow kicked off, and it went through all of these tasks successfully, and so we get a little green check mark. And in fact, it's possible to create a little badge that you can add really anywhere. I put it into the README, but you can put it in the github.io file, your documentation system, and that tells you what the most recent status of that workflow is. Okay, so what we've seen so far is there are three kinds of tests for prototype style development: unit test, acceptance test, and integration tests. They vary based upon kind of how much of the system you're testing at once. And then we've seen that we can use GitHub Actions to basically automatically run these tests whenever something happens to the associated GitHub repo. And the most common thing is to run the tests whenever there is a commit made to the master branch. And so people working off in their own branches, they may be deliberately committing code that they know doesn't pass tests yet. And so you could run the tests based upon every push to any branch. That's certainly an option if you want. It's more kind of common to say only run these continuous integration tests when on the master branch or main branch, as a way of saying to developers, at that point, you have to make sure that the tests are passing. So we've talked a lot about how to test. In fact, that's all we've been talking about. We've talking about like the kinds of tests, how you actually do tests. The final question is, well, how do you decide what it is you're even going to do? Like, what are the tests that you want to write? And that is an incredibly complicated question to answer, and deserves, again, whole books are written around the art of designing tests. So I'm going to reduce it all to one slide, which means this is a very oversimplified answer. But in the case of prototype test development, I think there's kind of 3 criteria that you want to think about in terms of building tests that actually help increase the velocity of development. With respect to unit and integration tests, I think you want to look for complicated computations. And instead of waiting until you've got the whole system integrated to see it, implemented to see if this complicated computation actually computes the right thing, then figure out a way to design your system so that you can test those complex computations in isolation. And then you can, as you make it more complicated or things happen, you can basically focus in on that complex computation and make sure that it's doing the right thing. At the acceptance test level, I think you start by basically saying, my system should be available. When I go to a page, it should display. When I, fill out a form correctly and submit it, it should succeed. Okay? So, this has been referred to as happy path testing. All right, and there may be certain kind of error conditions that are really important to your applications, and then so definitely check those as well. But in terms of a prototype scenario, okay, at least getting to the point of availability testing will add a lot of value to, or will definitely increase the velocity of development, because one of the most common things that happens in early stages is you write some new code and you've broken some other pages. And so having tests, if you've got 30 pages in the system, having a test that will at least retrieve all those pages and make sure they display, and at least submit all the forms in your system and see that they work correctly with acceptable correct inputs, that provides a lot of assurance to you that what you've added hasn't inadvertently broken something. It doesn't at all make sure that your system works correctly in all cases, particularly edge cases. But in terms of, again, velocity of development in the early stages, this investment will for sure pay off. Okay? And then finally, anything else where you get the feeling that this particular code is susceptible to the ripple effect, other kinds of enhancements later on in the system could impact on this. And again, this is hard to, kind of get really precise about. But at any rate, you want to check to make sure that those pieces of the code have been tested, so that if they're impacted by future enhancements or changes, you can see it. All right, that's my very simple introduction to testing. Hope you liked it.